the map. Okay, so we kind of redrew the map yesterday. We took a second to talk about how it's the same exact map. The only step that we added into it was this little funny bridge, right? We added in a little mole bridge. Basically, anytime you've converted to be a mole, now that we're approaching stoichiometry problems, which is comparing things across a balanced equation, we have to use a mole ratio where we're going to throw in those coefficients from your balanced equations, okay? So that is the only thing that changed. Okay, so last night's homework was pretty simple. You just had to start in moles and then go right into your mole ratio, multiply it by the mole ratio, and you got your answer. How many of you guys actually ended up doing it by like proportions, or you did it logically like in your brain? Good, okay, cool. So just so you know, today it's not gonna be as simple to do that, so make sure you find your way on how you're gonna show your work that way, okay? So just be clear on that. Just want to make sure you guys get that. Okay. Okay, so the next little bit that we're going to do, we're just going to take notes over all the calculations, and then you'll have plenty of time to practice it. So this first one, I'm not even going to look at the title. I want us to be able to do it by just looking at the problem. You already know where we're going, though. So we have, what is the mass in grams of glucose being produced when 3 moles of water, so I'm going to circle the information that's connected to the number, okay, when 3 moles of water react with carbon dioxide. So our goal is mass in grams of glucose, right? So do we even care about carbon dioxide? Because it's mentioned in the problem. No, it's just describing what the reaction is. By the way, what reaction is this? Photosynthesis, good. Okay, so now that we have that, let's talk about where we're going to go, and then we'll talk about the mole ratio. So approaching this, where are we starting? What unit are we starting in? Moles, right? Or we're in mole town. So if you're looking at the little map, follow along with that, okay? But you're in moles. So what do you have to do the minute you're in moles? Cross the bridge or use the ratio, right? So mole bridge, and I'll put ratio right underneath, okay? And then we can't stop there because most of these questions are asking for mass, right? So we have to go all the way over to grams, okay? So that's our route. That's what we're going to be doing when we're approaching the little math part, or the dimensional analysis, okay? Real quick before we get going on that, what is the mole ratio in this little photosynthesis reaction? Good. We have 6, 6, 1, 6. So remember, mole ratios come from these little coefficients in front of your different things. Okay, so we're going to take the 3 moles of water, okay? And honestly, I wish that it was written correctly like this so that you know that it's coming from the actual problem, okay? So the actual problem is where the 3 is coming from. So we have 3 moles of water. Okay, so from this point, remember the rest of that isn't there yet, okay, we would take our words and bring those down to the right, okay, so that would be your first step. Bring the words down to the right, and then you stop. You put your pencil down and you think about it for a second. You say, okay, I've already converted myself to moles. I've already traveled. I'm already in mole town. What's the next step? Cross, not yet. We got to cross the bridge first. We got to use our mole ratio. So this is the part where now we can relate things that are not the same compound, right? So this right here is our mole bridge, or mole ratio. So remember, these numbers are coming from where? The equation, right? So we get a 6 coming from right there. We have the 1 coming from right there. Okay? Now we're in moles of this glucose. Those come down to the right. Okay? And now we have to go to grams. We have to convert to grams. So in order to convert to grams, we're always talking about 1. And what is this big number that's up here? The molar mass, right? So using your periodic table, you added all those together to get that molar mass value. All right, and then that tells you that you're in grams of glucose at the top, so that's what they wanted. So now you can start plugging into your calculator. So you would type in the 3 times 1 times 180.18, push equals, and then you would divide by 6, divide by 1, push equals again. Okay? So this would be the answer that we would have gotten. So let's work through the next one. Since that one's already written for you, let's actually do one where we have a blank page. Okay? So for the next question, okay, so for the next problem, we have 3 moles of water. How many grams of oxygen will be produced? So we're going to start with that 3.0 moles H2O. Okay? I'm going to bring my words down to the right. Okay? And so now that I have moles down here, I'm going to stop. Think about what's going on. I'm already in mole town. I am already converted into moles, so I don't need to worry about any conversions there. I just move straight into a ratio or the bridge. And remember, the ratio or the bridge is where we change who we're talking about so we can relate water to oxygen. Once we've related those two, now we're going to go to their coefficients in the balanced equation. So in the balanced equation, the water has a 6. So I'm going to put a 6 down here. And my oxygen has a 6 as well. So we can put a 6 up here. Okay? I meant to have them all in pink, my bad. So then we would bring moles of oxygen down to the right. I would stop again, put my pencil down, and think about it. I've already crossed the bridge. I have to travel back to grams now. So now it's just a conversion. It's back to last chapter. So we have moles of O2. We're converting to grams. What is this relationship right here? How many moles? We're only talking about 1. And how many grams? Where are we going to get that information? Molar mass, right? So you guys have graduated from chapter 10. So now you guys can round up to 32.0. You've graduated to stoichiometry. Yay. Congratulations. All right. So you guys can use 32.0. I'm okay with you rounding that one, okay? You see that one show up a lot. I would say a lot of those diatomics, I'm okay with the rounding. All right. So now that we're here, make sure you practice real quick typing it into your calculator. You're going to see 3 times 6 times 32, push equals. Divide by 6, divide by 1, push equals again. And then you shouldn't be messing up. And that's always a safe way to type it into your phone calculators. Because phone calculators are kind of silly too, and they don't like parentheses and things like that. So once you have it, shout it out. 96. Is that what we're all getting? Okay, let's talk about sig figs for a second. Okay, you guys, sig figs real quick. How many should we have had?
3. 2.
It was 2. So, are we good? Yes, and then we have grams of O2. Okay, so the next one that we've got, okay, again, we're not going to worry about that title. We're just going to look straight at the problem, okay? Sorry for the blurry. But what we've got is we have 4 NH3 plus 5 O2 yields 4 NO and 6 H2O. So what's my mole ratio? A 4. What's the mole ratio? 5. Yep. 4, 6. Okay, good. Okay. The problem itself says that we are using 824 grams of NH3, nitrogen trihydride, right? How many moles of NO are formed? Okay. So looking at this, we know that we are starting in grams, right? So we're going to have our grams. What is our rule for stoichiometry? What does it have to be in order to relate it? What kind of unit does it have to be in? Can we relate? Okay. Can I relate 5 grams of hydrogen to 5 grams of oxygen? No, not really. Okay, you have to. It has to be in the mole. Do we got that? They don't mean this. Oh, no, maybe. Okay. Well, just keep working on it. All right. So we have to convert to moles. You always have to convert to that. Okay. Otherwise, use your map. You got to travel through Mole Town, right? So we got to get to moles. What happens the minute we are in moles? We always have to use the mole bridge or the ratio. Okay. I'm gonna put ratio because I have a little bit of room up here on my screen. All right. Okay. So now what we're going to do is, looking at that, we would start with that 824 grams of NH3. I would bring my units and the word or the label down to the right. I would stop, think about it. I have to convert to a mole. So I know that 1 mole of NH3 is its molar mass, right? So now I've converted 824 grams of NH3 to moles. Okay, so now I'm talking about moles. You can compare mole to mole. Those are the only things that you can compare. Okay, so we're going to take that moles of NH3, bring that down to the right. I'm going to stop, and I'm going to say, okay, I'm in moles. I've already done that. I have to now cross the mole bridge. So I'm going to change into moles of NO. Okay, and so these numbers right here, the 4 and the 4, where did those come from? The ratio, right? So your coefficient. So I had a 4 here and I had a 4 right here. That's what gets thrown in there. And then you're ready to type in. These numbers that are right here in your notes, do we know where they came from? Okay, they came from 824 times 1 times 4. That's this number. This number down here came from 17.04 times 4. Gave you that bottom number. And then you can divide those two. That is another way to do it if you don't like when I keep saying divide, 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 multiply, multiply, right? So if you don't like that, that's the other way to do it, is you could put parentheses around this whole top, multiply them, parentheses around the whole bottom, multiply them, and then divide those two answers. You are more than welcome to do it that way. But pick one way and do it every single time. Don't be changing it up on yourself or you're going to screw up on the test. Okay? All right. So when you type that in, I'm just going to cross this out so it doesn't confuse me. You should be getting 48.4. So let's try one together. We have 65 grams of oxygen gas. So we're starting in grams. How many moles of water will be produced? So I'm going to have 65 grams O2. I'm going to bring grams of O2 down to the right. I'm going to stop and think about it. I'm in grams right now. I have to convert. So realize the difference between conversion and mole ratios. I have to convert myself to be moles. I have to travel to Mole Town. So take a look at your map every once in a while if you're using that. Okay? 1 mole of O2, so only 1 mole of that molecule, is 32.0 grams. That's the molar mass. Now I'm ready to keep going. I bring my moles of O2 down to the right. Stop, think about it. I'm already converted to moles, so the next step is always cross your bridge. So now I can change into what the question is looking for, which would be moles of H2O. And I'm going to pull those numbers from my balanced equation. So I have a 6 from up there. So I'm going to put a 6 in that one. And I have the O2 also has the O2 has a 5. So I'm going to put a 5 here. Go ahead and type that in and make sure we can come up with the right answer. So I'll let you have a second to do that. All right, so we should have gotten 2.4. Is that what you guys got? Are my 6 bigs good, or do we need to change them? We're good. 2.4, because we had 2 given to us in the problem. So 2.4 moles H2O. Okay? Any questions so far? Okay, so this next one, if you go talk to people who have taken chemistry, they like to call this next one, quote unquote, the hard one. This is not difficult. If you've noticed, at this point, all we've done is we started in a new place and ended in a new place, right? And all we did was add in the one step to every question. So this one, we're just adding in that final step where we start in grams and we're going to end in grams, right? It's not going to be that bad, all right? Just keep following your process over and over and over. The way you know to stop on the little squares or on your little railroad tracks is you need to be ending with what you want at the top, okay? So let's go ahead and do this one. I'm going to torture you guys like I did morning classes. I want the name of this compound. So go ahead and write it off on the side of your paper. We have SNF2. SNF2. Good. Okay.
So then I multiply it by 2, which is the subscript of F next.
Mm-hmm.
And I got 2, and so you know it's the to equal out. So that's plus 2 on top, and then divide by 1, which is
Good. Yep. All right, cool. So once again, we had to figure it out because he was a transition metal. We had a -1 charge on our anion. Multiply it by 2 to get that -2. We have to balance it out with that +2. So this ends up being tin 2 fluoride. So make sure you're still practicing that, okay? All right, so I'll push that off to the side. We'll bring this back up here. Okay, so with our balanced equation, what is my mole ratio? I'll start you off. I gave you the 1. What's the mole ratio?
1,
Good job. 1, 2, 1, 1. Okay. All right, when we look at this problem, it says how many grams of SNF2 or tin 2 fluoride. So I'm just going to go ahead and underline that because I know that's where we're going. That's what the question is asking for. Are produced from the reaction of 30 grams of hydrogen monofluoride or hydrofluoric acid, okay? And then it says with SN. So this right here, this is useless information. We don't need it for the math part. So I'm just going to cross it out so I don't even focus on it, okay? I'm just going to start looking at this. So we would start with the 30 grams of HF. I put that in my first box. I would bring all of this down to the right. I would stop and think about it, and I'd say, okay, I have to convert to moles. When I convert to moles, it's always 1 mole, and this is always the molar mass of whoever I'm talking about, which moves me to the next part. And I would bring all of these words down to the right. I would stop, think about it again. I'm already converted to moles, so I've already started in moles. Now I just need to cross the bridge or use the mole ratio, right? So that's where we go in as one thing and you come out as something else. So we have moles of HF compared to moles of SNF2. So we're going to look at the moles in front of that one and the moles in front of this one. That's where we get a 1 and a 2. Then I'm going to keep continuing on. I'm going to bring those words down to the right and I just convert back to grams using, once again, 1 mole and molar mass. Okay? Once again, these numbers right here are just coming from multiplying across and dividing the 2. If you choose to do that, that's cool. Otherwise, just keep typing it in the way that I've said. And that's what we would have gotten. Okay? So, let's try one together. It's not too bad though, right? Like it's still the same process. If you notice, I haven't really changed anything. It's just a matter of you just gotta think it through. Okay? Think about your route. Conversions are always talking about 1 mole. The only time we use anything other than a mole is going to be when we have our mole ratio. Then you use coefficients, right? All right, so I'm going to start here. We have how many grams of SN will you need to make 100 grams of tin 2 fluoride? So I'm going to start with my 100.0 grams of SNF2. Okay? I'm going to bring that down to the right. I'm going to stop and think about it. So I'm like, okay, so I have grams. I have to convert to moles. Anytime I do a conversion, we're always talking about 1 mole, and this should be our molar mass. So I'm going to grab the molar mass from up here. So we should have 156.71. Wow, I wrote that really crazy. Can you see it? Sorry, you guys can see it okay? My bad. All right. And then we would bring our words right here down to the right again. So if you notice, I don't think until I've brought the words down to the right. Then I stop and think, right? So I've already converted to a mole. That's what that took care of. Now the next step, no matter what, as soon as I'm in mole, is I have to cross some sort of a bridge, or I have to use my mole ratio. So I'm going to cross the bridge. I have SNF2, and they want to know about tin. So we're going to say mole of SNF2 to moles of SN. Now I'm going to throw in my coefficients from the balanced equation. So I have a 1 up here, and I have a 1 down here. Cool, 1-to-1 ratio. I told you yesterday that's your best friend when that happens, because not a lot gets affected from it. All right, and then we're going to bring the mole of SN down to the bottom. Stop again. Think about where we're going. We need to end in grams, so I know that it's a mole to gram conversion. So 1 mole is the molar mass. So where would I get the information for right here? Where would I get that from? Your molar mass, your periodic table, right? So just to help you out and to speed us along, it would be 118.71, I believe. Okay? Okay. So go ahead and calculate that. Put it into your calculator. Don't look up here until you have done it. I'm going to turn on the lights so you guys can see your answer or your calculators. I will write the answer up here. Don't look until you're done. Okay? And don't forget, it's 4 sig figs.